So this is our distance ladder. And the cool thing about this distance ladder, because the question is, how do you know how far away something is in the sky? And the cool thing about this is that we have parallax, which is a geometric method, right? Once you figure out how far, and we've already talked about this, right? How big is the Earth? How far away Mars is? How big Earth's orbit is? And then we can actually use the orbit of the Earth as a baseline to look at nearby stars. Okay. Now, if you look at the North Star, do we know where the North Star is? Yeah, the North Star is. Do you guys know where the Big Dipper is? Aren't there 7 stars on the Big Dipper, dude? Right? 1, 2, 3, 4, 5, 6, 7. Right? These stars point to the North Star. The first bright star from these guys, if you just look at it, is the North Star. That's Polaris. It is above. It is above the North Pole within, I don't know, a fraction of a degree or something like that, right? Of the North Pole. Right now, the Earth's orbit is precessing and all this stuff, right? It also, by the way, is the end of the handle of the Little Dipper. Okay, but the North Star is. What did I read? I read some poem. Some poet wrote this poem. It was like scrambling through the brush, waiting for the North Star to rise. North Star doesn't rise unless you're like on the Earth traveling north, and as soon as you get across the equator, you could see the North Star, right? No, it's above the pole of the Earth. It's always above the horizon here. Yes. It's never going to set. It's always in the sky. There we have it, right? Okay. But anyway, so if you write poetry, do a little research first. But anyway, there it is. There's the North Star. That star is a Cepheid, or Cepheid. I really don't know. I like to say Cepheid because it sounds like maybe that's how you'd say it, right? It's a Cepheid variable star. These are standard candles. They are variable stars whose rate of change, in other words, they get bright and dark and bright and dark. You can map their rate of change. The period of a Cepheid variable is directly correlatable to its brightness, right? Type 1 supernova are also all about the same brightness, right? So anything below here has to do with brightness. You could draw a line. In your note guide, draw a line here. Okay? Right? Draw a little line and go, bah. Okay? This is all brightness. Distance relationship, right? It's inverse square law. This is all geometry. Geometry. Yeah? That's all geometry. That's all brightness distance. Okay? Somehow? But the cool thing is that we have parallax for a lot of these guys. We have parallax angles for a lot of these guys. So this is a good thing, right? And then since we can confirm the distance to Cepheid variables with parallax, we can do Cepheid variables. There's super bright stars. We can do those a long, long way out, right? And we can compare those distances to distances we calculate here, right? So a lot of these things overlap. Right, so we talked about measuring the Earth, blah, 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 right, the wells and all this stuff, right, and then how to figure out where Mars is, blah, 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 right, and then Earth's orbit, blah, 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 and then parsecs, indeed. So, okay, so we have parallaxes for about 10,000 stars, very accurate parallaxes, and then we can, another method for figuring out distance is to tell what the spectral type of the star is. If it is a main sequence star, you can see that it falls on the main sequence. Now there is some width to this, so this is not the best way, but then you can tell its absolute magnitude. And then if you have the absolute magnitude, what's the formula? It's like m minus m is 5 log d over 10. Is that right? It is? Is that the formula? Right? Okay. Right, right. This is the way they give it to you in the data packet, though. They changed it. Actually, they used to not give this formula in the data packet. Now they do. Okay? But anyway, if you know how bright it appears, and that's something you can measure by looking at the star, how bright it really is, you can tell that from this. Can't you calculate D? Yeah? Right? Or you can, how about this way, right? We can say that B, right, is L over 4 pi. This is the same thing, right, just written two different ways, right? If you can measure the brightness and know how bright it really is, right, and that's what this is, right? This is the intrinsic brightness. All of these correspond to a particular L, right? Then you can figure out the distance, right? So when we say brightness distance, that's what we're talking about. I give you guys a 100-watt light bulb, and I tell you guys at night to walk out into that parking lot some random distance from me. If I know it's a 100-watt light bulb, all I have to do is take one of those little photometers that photographers have, point it at you and see how bright you are, how many watts per square meter you are, and just, I know your distance. Isn't that cool? The farther you are, the dimmer you are. Right? Okay. Now there are variable stars. There's a bunch of different types of variable stars. And there are RR Lyrae cluster variables. These are ones that are in a particular spot of their stellar evolution, right? Cepheids, which are just supergiant stars. There's eclipsing binary stars, because they talked about, they had one question on the IBII test, is like, discuss the different types of variable stars, right? Do you know what an eclipsing binary is? Anybody want to guess? So they put a question about an eclipsing binary star on the IBII test. Yeah, most stars are binary stars. Most stars have stellar companions, like the star that Tatooine orbits. Yes, Star Wars. Yes, here we go. Right, an eclipsing binary. This is a non-eclipsing binary. They orbit each other this way. Yes, you see both stars all the time. Yeah. Okay, an eclipsing binary is that we happen to lie in the plane of their orbit, and every now and then one of the stars passes behind the other one. Right, and the question was this. It was like, you see blue shifted radiation, red shifted radiation, that is Doppler effect, right? Coming toward you is blue, coming away from you is red. Then you see no shift, then you see blue shift, red shift, no shift, blue shift, red shift, and then the brightness does this, right? What's going on? Well, it's an eclipsing binary. Mira variable stars are long period stars. And then there's stars that are just chaotic, right? Eta Carinae is just like blowing itself up, right? When it collapses, it has pair instability and it blows itself up, and then it gets dim, and then it collapses, pair instability blows itself up, right?
Is Eta Carinae the only?
It's one of the, there are other ones, I believe, yeah. Yeah, it's just the one we've got a pretty Hubble telescope because it's close. It's in the Milky Way, and we've got a nice picture of it blowing itself up, right? Here's where these guys are. The Cepheid variables are out here. There's dwarf Cepheids, right? White dwarfs. These guys can vary, right? Flare stars, I don't know what those are. There they are. RR Lyrae are actually in a particular spot of their in their evolutionary cycle. Red, semi-regular, irregular, and Mira variables. There you go. The giants, right? So there aren't so many that actually are on the main sequence, right? These are things that are post main sequence. The RR Lyrae, if you recall, what do? We go out here, red giant tip, then we're doing helium fusion, right? And then, isn't there something where we do like the collapse of the carbon core, right? It's right in there. Basically, you don't see people on a stellar evolutionary. This is a map of a globular cluster. All these stars have died, right? When this globular cluster was born, we had an entire main sequence. Now we've got a turn off here. There they go on their little road race, right? And then in this part of their evolution, they actually vary back and forth. And this is not a great way to measure brightness, but this is what they look like. And I'm not exactly sure what the mechanism is here, but they got a little bump like that. This is their brightness, right? So if you map the brightness over hours, and these are fairly short period ones, right?
So RR Lyrae stars?
They've left the main sequence, yeah. And they're going back and forth across that gap. That's why they don't show up on the map, because they're moving targets. It's like the blades of a fan. You can see through them, right? It's like they're there somewhere, right? Okay. You find it by the magnitude curve, right? Measure its apparent magnitude. They all have a magnitude of about 0 to 1, right? So now we know it. But this is, by the way, quite a wide range, isn't it? Yeah. This is not the greatest, but it's one way to do it. So again, we've gone back to this. We know this, and we know this, and we can find that, right?